Right, 3.6, polynomials of the form ax squared plus bx plus c. So this is similar to the last video, except in this video, we've got a number here. So it's not just x squared, it might be 2x squared, 4x squared. There's a number there that we have to deal with, as well as the other two, the b's and c's that we've talked about previously. So this changes things a little bit, but we can do it. So first let's expand, and this expansion is a little bit different than the ones that I used in the last lesson to preface factoring, because we have numbers in front of our d's here as well. So when I expand, I'll have 3d times 4d. You know what, I'm going to write it all out again, plus 3d times 1. And this, I've got a note here. I changed this number from what was originally in your notebooks, so just make sure that you're working off the same problem as me. This is now plus 1, not whatever else it was. I'm not even sure what it was. Plus 4 times 4d plus 4 times 1. Okay, so I've got 3 times 4, which is 12, and d times d squared, plus 3 times 1, 3d, plus 4 times 4d, 16d, plus 4 times 1, 4. All right, I group my like terms, so the ones in the middle here, and I get 2d squared plus 3 plus 16, 19d plus 4. All right, so that is our expansion, taking my two binomials and making one trinomial. So just as before, factoring, we want to do the opposite. We want to work back up. So if we look at our 4, I still got that by going 4 times 1, right? These two numbers on the outside multiplied together is what's getting me my c variable. Okay, if I look at my a variable, the one in front of the d, so I have 12d squared, and that's these numbers multiplied together. 3 times 4 gave me 12. Okay, so that part's okay. What is more interesting is this b number. So b is no longer just the 3 plus 4. It's more than that. It's sort of 3 times this one, 4 times this one. But I have this addition, and this combining of my like terms step is what's interesting and what's sort of important and what we're going to be focusing in on when we are factoring the polynomials in this form. Right, so let's look at an example, and I think it'll start making a bit more sense. Now in your books, it says factoring by logical reasoning. We'll come back to that, right? And like in another video, or come and see me if you want to see that method. I like factoring by decomposition, which is the next one. I think it gives us more of a process, right? I know you like having steps to follow. So let's factor by decomposition. That's what we're going to do today. We're just doing decomposition. I'm not even going to look at logical reasoning. Logical reasoning needs you to know a lot of your sort of multiplication tables and being comfortable with that. Decomposition still helps if you're comfortable with your tables and factors, but it is more of a step-by-step process, which I find really helpful. So here we go. I'm going to decompose my middle term here. So what I mean by that, I'll think of decomposition in like a science method, or decomposers. They break things down. So I want to break up my 11g very specifically so that I have 4g squared plus something g plus something g plus 6. And these two things, of course, have to add up to my 11g. Now, if I just scroll up here, right, I had the 19d, and it came from this addition sentence, that statement there. That's key. That's helpful. That's what I'm going backwards. That's what I'm decompositioning. Now, when I'm breaking up this number, I want to do it very strategically because I want this to make my life easier. So I want it such that these first two terms will have a GCF that I can factor out. And these two terms, maybe I should put this bracket on the other side of that plus sign because I'm not multiplying. Right? And these two terms here, again, will have a GCF that I can factor out. Now stay with me, right? I know this is a little crazy, but 11g, right? So 11. So I need to break that down into things that add to 11, but are going to get me a factor with 4 for one and a common factor with 6 for the other one. So unless it just comes to you, a little bit of trial and error is going to have to happen. So I could do like 4 plus 7 would equal 11. That works for my 4 because then I'd have a GCF of 4, but it doesn't work on the other side. So that's not going to work for me. I can look at it as 11 minus 6, but then I have 5 here. So it needs to work on both sides. So something else I can look at is 3. So 11 minus 3 is 8. All right, well, that works on both terms. All right, so if I put my 3g here and my 8g there, notice my 4g squared plus 8g. Those have a common denominator, and 3g plus 6 also has a common denominator. So let's work with this. Let's take out this GCF. So 4g squared, so let's just look at the GCF, sorry. Let's not get ahead of ourselves. So my numbers, I've got a 4 and an 8. So my GCF is 4. But I've got a g squared and a g, so I can take out a g. And this is always going to happen when we do it by decomposition, where we can take out one of your variables from the first two terms here, and that's important. And you'll see why in a second. But if I do that, I factor out by 4g, so my 4's cancel, this g will cancel, and I'm left with 1g, plus 8 divided by 4 is 2, g divided by g cancels out, is just 1. Okay, so I've got 4g times g plus 2, plus GCFs on this side, that's going to be a 3, and I only have one term with a g in it, so I can only take out 3. And again, that will always happen. The second term, I'm only going to be taking out a number or a numerical GCF. 3 divided by 3 is 3, so I'm left with g, plus 6 divided by 3, which is 2. Okay, so something really special happened here, and if we're doing our factoring by decomposition right, it will always happen. I've got g plus 2 and g plus 2 here. Right? I need that to happen for me to do this next step. And my next step, the math behind it, perhaps a little complicated, but I'm okay if you just remember what we need to do here. So I'm technically factoring out a g plus 2 from both of these terms. So this is technically what I'm doing and why. I have a g plus 2 right here, a g plus 2 here. So I am technically dividing both terms by g plus 2 and factoring that out. That is my GCF. So I'd have g plus 2, and then brackets, whatever is left, 4g plus 3. All right, so that's the technical side of what's happening. I am 100% okay if you see this and you go, I've got my g plus 2, so I write that once, and then everything that's outside of it goes into its own bracket as well. I'm okay if you're just remembering what's happening here, but it is important for you to see that there is that mathematical reason behind it. It is technically this step here, from here to here, is technically a GCF factoring, with the GCF being g plus 2. Right, so that's technically what's happening. But again, I'm okay if we've got it here twice, so I write it once, and everything outside is its own brackets as well. All right, and then that is our answer. Right, so that is our factored form of this trinomial. Now, it's always good practice and important for us to verify. That is when we are going to expand this out and make sure that we are correct. Right? That's the lovely part of this chapter, is you should at least know if you're wrong. Might not know how to fix it, but you should know if you're wrong, which is powerful in itself. So g times 4g is 4g squared, plus g times 3, that's 3g, plus 2 times 4g, 8g, plus 2 times 3, 6. All right, so I'm getting 4g squared plus 11g plus 6, and yes, I am correct. All right, so that's how we verify. We do that multiplication expansion, and we make sure that we indeed get the same trinomial that we started with. All right, so we're going to do that a few more times. I know it feels a little crazy when we start doing it, but the more we do it, the better it's going to feel. All right, so again, let's start with an expansion. And this one I'm going to do with the area method, so we are seeing both methods here today. So I have 3h plus 4 and 2h plus 1. All right, in this box, I do 2h times 3h, so I get 6h squared, 2h times 4, so 8h, 3h times 1, which is just 3h, and 4 times 1 is 4. So I end up with 6h squared plus 8h plus 3h plus 4, and I combine these terms, 6h squared plus 11h plus 4. Right, and that is how we do this expansion. So remember, as we go backwards, we'd break up this 11 here in such a way that I have these common factors. Now my order from before wouldn't work that great, right? 6 and 8 do have a common factor, but 3 and 4 don't. And that's totally okay. What I'm going to do instead is just switch the order. Do 3h plus 8h plus 4. And that, of course, doesn't change anything, right? If I have 2 apples and 2 oranges, or 2 oranges and 2 apples, I've got the same amount of fruit. the order of addition doesn't matter. So switching these orders around, that's okay. We can do that, and we do that a fair bit, so just keep that in mind as well as we're going through this. Okay, you know what, I'll just keep going here because it does say to factor by reversing the steps. So let's keep continuing on with this here, and let's continue to factor it. So my GCF in these terms, so I have 6h squared plus 3h. So I can take 3 and 1h out of both of these. So when I'm factoring, I bring that out front, and I bracket and whatever's left. So 6 divided by 3 is 2. H squared divided by h is h. And then I've got 3h divided by 3h. So that is indeed just 1. All right, and my next term, I've got 8 and 4. So I can take out a 4. And I only have 1h, so I can only take out the 4. Now this is looking good because I want to have 2h plus 1 in here, and I do. Right? 8 divided by 4 is 2, and the h stays right where it is. And 4 divided by 4 is 1. So I am feeling good about this. So I've got 2h plus 1. And outside of the brackets, I have 3h plus 4. So I'd write them both like this. And if we look back at the very beginning, that is indeed what I started with. Right? So that's how we do this factoring by decomposition. Practice here is key. Right? If you're not practicing this, it's not going to make more sense than it does at this moment. It's going to, in fact, make less sense the next time you look at it. So we need you to be practicing here. All right, so let's do some practice together here. So 3s squared plus 13s plus minus 10. All right, so just double check with each of these that you're doing the same question as me, depending on when I printed your book. You might have a different question here. So just make sure everything is the same. 3s squared plus 13s minus 10. Okay, so I need to split this up so that I have 3 s squared plus something, then plus something else, s minus 10. So these s's need to have common factors with the 3 and the 10 on this side. So I'm going to bring out plus 13, so this is going to be plus 3, and this one plus 10. Oh wait, you know what? I don't want to do that. Why don't I want to do that? That's a good question. Let's talk about that before I just say I don't want to do that. I don't want to do that because, if you remember from before, I need these terms here. Oh, I don't want my eraser. I need these terms here to be the same. If I'm looking at this, I have 3s squared plus 3, 10s minus 10. I have different signs. I have a minus 10, so I have a negative sign. So when I'm doing this, because this is negative, kind of like before, when I had negative multiplication, meaning one is positive and one is negative, I need to do that the same with my s here. I need to split it up. So I have one negative and one positive. Right, and the only way that I can do this properly is to have 15s and minus 2s. Right, that's the only way that's going to give me a GCF. So on the second section, I have 2 that I can take, 5 that I can take out of both of these terms. Now on this section here, you might be thinking there is no GCF here, but there is. Right? There's no numeric GCF, but I can take an S out of both terms. So sometimes that's the best I can do. So in this case, that's all I've got. So I'm just dividing both of these by S. And I'll be left with 3 minus 2. Sorry, 3S minus 2. Okay, and then on our second term, now I do have a GCF I can take out, a numeric GCF, and it will be 5. I'm going to divide both of these by 5. And 15 divided by 5 is 3. The S is along for a ride, and oh yeah, minus 10 divided by 5 is negative 2. All right, so these two things here are exactly the same. They're identical. So I write that once, 3s minus 2, and everything outside of the brackets I put inside of their own brackets. So 3s minus 2 times s plus 5 will be my factored form of this equation here. Right, and we can verify. I'll just do a quick verification here. So 3s minus 2 is s plus 5. So 3s times s, 3s squared, 3 times 5 plus 15s minus 2s minus 10, 3s squared plus 13s minus 10. We are golden. There you go. So that verification step is huge. It really does help you make sure you're right. And on a multiple choice test, if you get stuck, sometimes this verification step can help lead you into the answer in a bit of a roundabout way. All right, so let's look at our next question. Now for our next question, the most important part is that you do it the easy way. There's an easy way and a hard way. We want to go the easy way all the time. So 6, 21, and 9. What do you notice about all three of these numbers? They all have something in common, a number in common, a factor in common. They all are divisible by 3. So the easy way of this question is to start by taking out that 3. Do a GCF factor of 3. So now 6 divided by 3 is 2. So I have 2x squared minus 21 divided by 3, 7x plus 3. All right, so that is going to be our easy method, is starting with that. If you don't start with that, it gets a lot harder, and it's just dealing with bigger numbers, right? 6s, 21s, 9s. I don't want to deal with those big numbers. So factoring that 3 out first is helpful. So do that first. All right, so now I have a similar type of question as the previous one we just did, except instead of the second one being negative, instead of the 10, right, this one here being negative, I have my middle one as negative. So what that means is, this is a positive, this is a negative. So I would have 1 being negative, and in order to get a positive, the other one also has to be negative, right? I need to have a negative times a negative to get a positive. So that's just something that we should keep in mind as we start doing this decomposition here. So 2x squared, and I want it to work out so that I have some common factors in this here. And so in order to get these double negatives, both of them are negative, both of these are also going to have to be negative. So I need two numbers that are going to add up to this negative 7x and give me some common terms that I can then use to factor out. So I'm looking at the 3, and I'm seeing 7, and I'm thinking 6, right? That's going to give me a nice common term I can take out of the second section. And the other one then would just be negative x or negative 1x. Again, that works out fine because I still have that x that I can take out of here. And don't forget about this 3 on the outside. It's just going to stay on the outside as we go through the rest of the steps here. But don't lose it. It's still important. Without it, we can't get back up to this, so we need that 3. All right, so from these first two, I take out my GCF, which is an x. So 2 divided by x is still 2. X squared divided by x is x. And negative x divided by x, negative 1. All right, and now I look here. Now I need 2x minus 1. So I'm going to take out from both of these a negative 3. So I'm going to have negative 3 on the outside, and 6 divided by negative 3, sorry, negative 6 divided by negative 3 is 2x, and plus 3 divided by negative 3 minus 1. Okay, and I double close the bracket to keep the 3 in the loop here too. And I end up with 3. I've got 2x minus 1 in both of these. 2x minus 1. And here, x minus 3. So this is how I would write that out here. The 3 just keeps following itself down all the way through. Don't lose it. And my breaking up by decomposition. All right, so making sure that I'm still getting this original number here as well. All right, and again, let's do a quick verify and make sure we're on the right track. So I'm going to start on the inside. So 2x times x is 2x squared. 2x times negative 3, negative 6x. Negative 1 times x minus x. Negative 1 times negative 3 plus 3. So I'd have, oh, wrong way that bracket went. 3 times 2x squared minus 7x plus 3. So that looks good, but let's get right back to the very beginning and multiply out that 3. So 3 times 2, 6x squared minus 3 times 7, 21x. And 3 times 3 is 9. And that is good. That is right where we started with. So we are good to go. All right, so again, factoring, whether we have the a value or we don't, it's all about practice. So now is your time to practice. If you're getting stuck or having questions, please ask, because that really is the best way. Do the work, and when you get stuck, ask for help. That's how we're going to get better.